Hello everyone, it's Mr. Rops here, and we're going to do a linear application. Okay, so here's our clue. Take a moment, read this. We'll read it together. It says, a waiter in North America gets tips, and notice on average, and in North America, there's lots of tips are given. On average, if he has 2 customers on a table, so C for customers, he gets $5 in tips, T. If he has 10 customers at his table, he makes $40 in tips. He assumes a constant rate of tipping. All right, so there's my clue, and I have to try and make an equation, a graph, a table, and then even answer all these questions here. So let's go and see what we can see. So from here, I can fill in part of my table. I know if I have 2 customers, it says I make $5. And if I had $40, I had 10 customers on my table. And I can even come along here and graph it. So 2 gives me 5 approximately, and 10 gave me 40. And so I get a line there, and let's see if I can create the line approximately here. Okay, so there's my line, but I can find these values. I need to find the equation. And so remembering finding some of our equations, I have to find the slope first. And the slope is equal to the change in y over the change in x. But I don't have x's and y's here. I have t's and c's. So it's going to be the change in t's over the change in little c's. So my change in t's are going to be 40 minus 5. And my c's, I can use 10 and 2, which is 35 over 8. And if I quickly type that out, I know it's 4.375 is my slope. And so if I look here, I know my slope is 4.375. But if I want to explain in context, I know that this is 4.375 over like 1. There's a 1 there. And this was tips, which was dollars, and this was customers, C, customers. And so if I want to interpret this value, I know for each additional customer, on average, I make $4.375 in tips. So when I interpret this in context, I always start with, like, quote unquote, the x value, the independent variable, and discuss that first. So if I write this out, it's going to be for each increase of one customer, on average, the tips increase by $4.37, so which is not even a full penny, but that's on average what it on average. Okay, and so that's how I done it. Note when I do the slope, I talk about both variables. The units are included, and it's on average the tips. All right, so there's my slope in context, but I also need to find the equation. And if we remember the equation, I can use this formula, x minus x1. But if I adapt this formula, that's the same as saying t minus t1 equals mc minus c1. And if I decide to use, let's say, this point here, I go t, well, this is t1, it'd be 40, equals, my slope is 4.375 c minus 10. Okay, I distribute my values, I get 4.375 c minus 43.75. If I come, if I come along and add my 40, I get t is equal to 4.375c minus, if I add 40, 3.75. And so this is a linear equation, or linear function that relates the number of customers to the tips. So I get 4.375 C, not equals, plus 3.75. So there is my equation. So if I want to find the value here, I can type this into my function. If I clear this and clear that, turn that plot off, I can say 4.375x plus 3.75. And so if I want to, when it's 5, I can go, if I hit trace, oh, my window's all wonky. Let me go back to my, I'm going to zoom to a, well, here's my graph. Let's go to my window actually. Let's go from 0 to 10. And the scale will go by ones. And then my Y minimum, let's go from 0, let's go to 100. And let's go by tens. So now when I hit the trace button, there's my graph. Everything's typed in okay. If I type in 10, if I've done it correctly, I should get 40. Oh, I don't. Uh-oh, what did I do wrong? Oh, minus. And this here says plus. Minus. Now if I graph it, let's see. There it's there. And if I trace, if I type in 10, I should get 40. If I type in 2, I should get 5. Super. So I also want to type in 5. That gives 18.125. If I want to find 0, I type in 0, and I will get negative 3.75, which I knew was my, if I write it here correctly, is my y-intercept. Okay, so continuing along, let's look at what else we need to answer here. So I want to find the t-intercept and the c-intercept, and if I recall, I know that t of c is equal to the 4.375c minus 3.75. So if I want to find the t-intercept, if I think about the t-intercept, if I go back a page, I know that this is c and this is t. The t-intercept is where it crosses the axis here. Well, that's going to be this value here. The t-intercept is negative 3.75. And what that means is that if there are 0 people or customers, then negative $3.75 is expected in tips, which I know is ridiculous. Okay, but that's what it means. And oftentimes the y-intercept or the t-intercept in this case doesn't make any sense. If I want to find the c-intercept though, that means I'm going to make t 0. Because if I want the c-intercept, I'm looking for where does it cross here. And I know it's c comma 0 of some kind. And so I make t 0. I go 0 is equal to 4.375c minus 375. And I'm going to move this over 3.75 and then divide by the 4.375. And when I do that, if I want to try that, I'm going to go 3.75 divide 4.375 ends up being 0.857 customers. So that means that when the tips are $0, there are 0.857 customers, which again is ridiculous, but that's okay. Then it wants to show if this is true. So to try this one, 18, t at 18, well, that's 4.375 times 18 minus 3.75. If I go to here, I'll show you a new way of trying it. If I go alpha trace y1, and if I type in 18 and enter, it will find me the value. It equals 75, and so this is a true statement. Okay, looking at the details, determine the amount of tips for 8 people. Well, determine the amount of tips for 8 people means I'm going to make C equal to 8, so I'm looking for T at 8. And if I can go to my calculator again, I can just do T at 8. Oh, didn't like what I did. Let's see. Oh, missed the parenthesis. T at 8, which is, I should get 31.25 in tips. Similarly, to determine the number of people if there was a tip of 22.50. So that means 22.50 is the tip. I want to find T at C. I want to find C. In order to do this one, if I go to Y equals, I'm going to make this 22.5. I'll look at my window. I go 0 to 10. Y scale of 10 to 1,000. Oh, that's kind of, sorry, this is 0. To make it actually 100, I can see it better. So we'll graph that. And I'm looking for the intersection. And so if I go second trace, I'm going to do intersect. Well, that's my first equation. That's my second curve. And I'm going to just, and so it, C should be 6 customers. In a practical sense, what is the range of possible amount of customers on a table? Well, I know the customers on a table has to be bigger than or equal to 1. I can't have 0 customers on a table. That's and get a tip. That doesn't make any sense. And I also know it has to be whole numbers, positive or positive integers. So I can write positive integers, or C belongs to the set of positive integers. And so I could, in theory, have 1,000 customers on a table or 1,000,000, but these are possible values. But it has to be whole numbers, and it has to be bigger than or equal to 1. So this is the possible range of customers on the table. The range for possible tips earned, well, I know if there's one customer, if I had one customer, if I trace at 1, that means I've made 62.5 cents. Well, if there's one customer, I have 0.625 as my tip. But in practical sense, I would say anything when T is bigger than or equal to 0. This is a practical sense. I can't have negative tips. I could only have 0 or bigger. Limitations to this model? Well, there are lots of limitations to it. The one thing is we are assuming that everyone tips in the same way, and that it's going to be this graph that goes on forever, and that if there's one person, it's exactly so much money. If there's 2 people, it's exactly so much money. And there's lots of limitations. We also, it's not a line. It's really just a series of points, right? We can't have 1.5 customers. We can only really have solid whole numbers. So it's just a series of points. So that's another limitation. It is a discontinuous graph, and we assume a constant rate, but that is not a very safe assumption. There's some applications for you.